Hello, algebra students. It's Mr. D'Amico with another math lesson for you. Today we're going to be talking about solving quadratic equations by completing the square. And luckily our formula and our rules will look slightly less complicated than this. Our goal for the lesson is to solve a quadratic equation by completing the square. And if we recall, so far we have learned two other ways on how to solve quadratics. We have solved by graphing, in which we graph a parabola and see how many times it crosses the x-axis. We've also solved by factoring, which is something that you learned how to do in Algebra 1, and we reviewed it in the last couple lessons. So today we're going to solve quadratics a third way by completing the square. And previously we used completing the square to take an equation that was written in what we called general form, and we used completing the square to write our quadratic in what we called vertex form. So we're going to use those same rules, that same process, but now we're going to actually solve the equation. The first thing that we need to do is we would like to set our equation equal to 0. In other words, we're going to take the y value and substitute that in for 0, as you can see like I did there by writing it 0 over y. Why do we set the range or the y value equal to 0? Well, if we remember from graphing parabolas, the solution to a quadratic equation is we want to find out where that parabola crosses the x-axis. We also call those the x-intercepts. And if we remember, anywhere we go on the x-axis, the y value is 0. So by setting y, or the range, equal to 0, we can then solve for the values of x that will basically be the x-intercepts, or the solutions to the quadratic. Alright, so I'd like you to write the rules down on the right hand side of your notes. Step 1 is to set y equal to 0, which we already did. And then what we're going to do is we're going to move the c value to the other side of the equation. So in this case we would add 12 to both sides, giving us 12 equals x squared plus 4x. That's going to set us up for completing the square, so we're going to move c to the other side. And then if you remember, the process now entails, for completing the square, we take the b value, we divide it by 2, and then we square it. So the b value is 4, as you can see right there. We take that 4 and we divide it by 2, and then we square it. So 4 divided by 2 is 2, 2 squared is 4. And then what we do with that value, in this case our value is 4, the value after we square the b divided by 2, we take that value and we add it to both sides of the equation. The reason why we have to add it to both sides of the equation, if we don't do that, we're not treating both sides equally, and therefore we are changing the equation. So what we're going to do is we're going to add 4 to both sides, because again, what we're getting here is we're taking this number here, 4, and we are adding it to both sides. Therefore, the equation is still going to be equal. So what we have there is x squared plus 4x plus 4. That's our perfect square trinomial. And now we are able to factor that perfect square trinomial into a binomial squared. Again, the whole point of completing the square is to get a trinomial that you can factor down into a binomial squared. And we're going to have something that looks like this. So there's a couple ways you can do this. You can ask yourself, you can say, what numbers multiply to give me 4 and add to be 4? And remember, since it's a binomial squared, it's a number times itself that equals this 4. So 2 times 2 equals 4. Or another way that we can think about it is whatever b divided by 2 is, which is this value right here, that will go into our binomial squared as well. So since that's a positive 2, we're going to get, in this binomial, an x plus 2. Also, 2 times 2 is 4. That's why it works for the c value. And then 2 plus 2 also equals 4. That's why it works for the b value. We can also then simplify the left side to get 16. And now we have 16 equals the quantity x plus 2 squared. So what we're going to do next is, again, we're solving for x, and our last step is to solve the equation. So we want to think about doing the opposite now. Well, the opposite of squaring something is taking the square root. That's the opposite operation of squaring, again, is taking the square root. So what happens when we take the square root of something squared? These operations cancel. So the square root of something squared, those will cancel out, leaving us with an x plus 2. Over here we have the square root of 16. That actually has two answers. The square root of 16 is positive 4 and negative 4, so we indicate that by plus or minus 4. And now we need to solve for x, so we would subtract 2 from both sides, but because we have two different values there, we have positive 4 minus 2, that's going to equal x, and we also have negative 4 minus 2, and that's going to equal x. So there's going to be our two different values for x. So 4 minus 2 is 2, and negative 4 minus 2 is negative 6. So our two x values are going to be negative 6 and positive 2, which means they would cross the x-axis at the points negative 6, 0, and 2, 0. Those are our x-intercepts and or our solutions to completing the square. Okay, problem number 2. Again, our first step is to set the range equal to 0, so I'm just going to replace y with 0. And then I'm going to move the c value to the other side. So I have negative 23 equals x squared minus 12x, and now I'm set up to complete the square. So I'm going to take that b value, which is negative 12, and divide it by 2. That's going to give me negative 6. Then I'm going to square it, and that gives me positive 36. That's the number that I'm going to add to both sides to keep the equation balanced. So you can see there that I added 36 to both sides. Now that sets me up again with what is called my perfect square trinomial. And again, I'm going to factor this into a binomial squared after I simplify the left side there. Negative 23 plus 36 is 13. And then I look at this and I say, okay, I have two options. What number times itself equals 36? And again, I say what number times itself because, again, the whole point of completing the square is to factor down into a binomial squared. So it's going to be a number times itself that equals 36. And that same number times itself that equals 36 has to add to be negative 12. So it's going to be a negative number. Negative 6 times negative 6 equals positive 36, and negative 6 plus negative 6 equals negative 12. Again, we can also remember that if we go up to this number here, whatever the number b divided by 2 is before we square it, in this case negative 6, that will also go down here in our binomial squared. So there's the x minus 6. And then we are ready to go ahead and continue solving. So again, we want to do the opposite. The opposite of something squared is to take the square root of it. So we do that to both sides. Taking the square root and squaring are opposite operations, so those cancel out. So we're going to be left with x minus 6 equals. Now, the square root of 13 is not a perfect square. It's a decimal if you try to do it on your calculator. So we're going to leave it right now as plus or minus the square root of 13. Because remember, when you take the square root of a number, you get a positive and a negative answer, indicated by the plus or minus square root of 13. To continue solving for x, we can add 6 to both sides. So we have 6 plus the square root of 13 is one value of x, and 6 minus the square root of 13 is the second value of x. So what we can do with this is we can write our answer. This is the exact answer because remember 13 is not a perfect square. So we can write it as 6 plus or minus the square root of 13, and we could leave the answer like that. Or if we want to find out what the square root of 13 is on our calculator, we can do 6 plus the square root of 13, which is approximately 9.6. And we could also approximate on our calculator 6 minus the square root of 13, which is approximately 2.4. And again, if we wanted to write those answers as x-intercepts, because that's really what they are, we could say that the final answers are 9.60 and 2.40. Again, that's where the parabola would cross the x-axis at those 2 points. And there you have it for problem number 2. Our final problem, if we set y equal to 0 again, and we go ahead and subtract 10 from both sides to move the c value over, that leaves us with negative 10 equals x squared plus 5x. And then we are ready to complete the square. Now notice this time the b value is odd. We're still going to do b divided by 2, which is 2.5. And then we're going to square it, which is 6.25. What we can do then is we're going to take that 6.25 and we are going to add it to both sides to make sure the equation is balanced and stays equal. So then we can simplify the left-hand side there, and that will give us negative 3.75. And again, we're looking for a binomial squared. So if we go back to this, now this gets a little bit tricky. We could say what number times itself equals 6.25, or we could go back up and look here, because remember, this number, before we square it, the b divided by 2 is always going to go into our binomial squared. So since this is a positive 2.5, our binomial squared is going to be x plus 2.5 right inside there. And if we wanted to check on a calculator, we could do 2.5 times 2.5. We would get 6.25, and we could also add 2.5 plus 2.5, and that would give us 5. All right, let's take the square root of both sides now, because we want to do the opposite of squaring. If you try to take the square root of a negative number, your calculator is going to give you an error message. For right now, that means there's going to be no solution. The actual solution is going to be an imaginary number, and we're going to learn about imaginary numbers in the next few lessons, but since we don't know anything about them right now, we're just going to say that this equation has no real solutions. To give you an idea what the graph would look like, if we have two solutions for x, remember the parabola crosses the x-axis twice, and if we have one solution, the parabola will touch the x-axis once. This has no solution, so it does not cross the x-axis at all, so the graph would look something like that. There you have it. Please try the problems on the back side and come ready with questions tomorrow. I can't wait to see you all tomorrow and answer your questions. Thank you for watching.